This tutorial introduces how to use the CFD module. We have a 10 by 6 loop field with 20-foot spacing and 277-foot deep boreholes. Now, we need to optimize the piping system so that the system is purgeable and operates efficiently. Here, we see a headering system with reducing headers so that the system is purgeable. We will now design such a system using the CFD module. We open up the CFD module by clicking on the pipe icon. Right-click in the Design workspace and select Add New GHX Module. Enter module-specific information so that it matches your bore field design. For this particular design, we will be using a 3-inch header pipe size. We now define the supply return runout length and pipe size. We click OK to build the GHX module. We now see the GHX module, the supply return runout, the first borehole, first header section, etc., all the way to the last circuit. The CFD module offers the designers a great deal of information. With the multi-select option, the user can choose what information he or she wants to see. In this case, we choose the size, type, and length of the pipe. We can also choose Review Mode to see everything displayed vertically. Notice that so far in the design, all header sections are 3-inch pipe. To auto-design the headering, we switch to Purge Mode. We set the controls to auto-design the purging flow rate and the header sizing. We hit the Auto Size button. The program has calculated the optimum header sizing. We deselect the borehole circuits to look only at the headers. Because 2.5-inch headers are an unusual size, we deselect them and then auto-size the headers again. We choose to look at flow rates and velocities to see how our purge-optimized system performs. The entire headering system is achieving 2 feet per second velocities or higher. We look at the circuit or borehole performance as well to ensure that 2 feet per second is being achieved. Now that we have designed our piping system, we switch to peak load mode to simulate operational performance. We first review our flow rate, and then we choose the proper solution for our design. We choose to see the Reynolds numbers as well. We adjust the visibility controls to maximize ease of use. We hit the Calculate button to see Reynolds numbers under operational conditions. We can also review total pressure drop. We switch to the Design workspace to continue building our system. We can copy and then paste our purge-optimized GHX module. We can now add a manifold system. We define the manifold including the number of supply return runouts, the separation between runouts, and various pipe sizes. We can also define the mains coming into and out of the manifold. We can now see the manifold. We can also drag and drop our completed GHX modules onto the manifold into the appropriate places. We change our flow rate to represent the entire system. We hit Calculate one more time and then review the final system. We return to Review mode to export our design to Excel.